When we see a bee flying around aimlessly from flower to flower, we often think that they are just randomly looking for something sweet to drink. However, have you ever noticed that whenever a bee flies away, it always returns to the same spot? In fact, the little bee is not aimlessly wandering around. It has a precise map of its surrounding flowers in its mind. Scientists believe that honeybees can memorize more than 100 locations of flowers within a radius of 1 kilometer. They know which flowers have nectar and which ones don't. They remember the distance between themselves and each flower, the direction the flower faces, and even the time the flower blooms, so that they can find a continuous supply of fresh nectar. So today let's take a look at these little guys and see how they memorize the location of so many flowers. Why do you think it's important to memorize the location of the flowers? What if there's a lot of flowers that have nectar? Do you think these bees will get lost? In fact, if a honeybee wants to collect pollen or nectar, it needs to visit thousands of flowers every day. If it doesn't have a good memory, it'll waste a lot of time repeating the same route and won't be able to collect enough pollen and nectar. This means that the bees wouldn't have enough food to eat. But how does a bee use its memory? Does it have a compass or an odometer to keep track of the distances and directions? How does such a tiny bee have such a good memory? There is a saying in China that goes, if you want to know the way, you need to ask those who frequently travel that road. So what better way to memorize the location of the flowers than to constantly visit them? A honeybee will fly back and forth between the hive and the flower several times until it knows exactly where the flower is located. The process starts when the bee first flies out of the hive in search of food. When it finds a flower, it will immediately begin collecting pollen and nectar. After drinking the sweet flower juice, it returns to the hive and tells its teammates where it found the flowers. But how does it tell its teammates the exact location of the flower? Is it through smell? No, that's not it. The flowers all smell similar. Is it by sight? No, bees can't distinguish colors. So the bees use another method to convey this information. They use a special waggle dance on the surface of the beeswax to convey the exact location of the flower to its teammates. This dance is called the waggle dance. Through this dance, the bee tells its teammates the direction, distance, and other information of the flower. Its teammates can then quickly understand the information and rush to the flower to collect pollen and nectar. You may wonder, since the bee communicates the information through dance, it must have memorized the location of the flower in its own mind, right? Yes, that's exactly the case. The dance moves become ingrained in the bee's memory. Whenever it performs the dance, it remembers the location of the flower. And whenever it wants to collect pollen and nectar, it just needs to perform the corresponding dance moves to find the flower. To memorize the location of the flower, the bee uses two reference points, the sun and the Earth's magnetic field. When a bee moves, it keeps the angle between the direction it's facing and the sun consistent. For example, if it keeps the angle between its body and the sun at 45 degrees, then no matter how far it moves, as long as it keeps the angle between its body and the sun at 45 degrees, it will eventually return to the starting point. This is like when humans use the North Star for navigation. Of course, bees don't have a sextant to measure angles, nor do they know the constellations. All they rely on is their innate ability to sense the direction of the sun. But why would a bee need to memorize the direction of the sun? Wouldn't it change throughout the day? That's right. The position of the sun changes as time passes, so the bee keeps the angle between its body and the sun at 45 degrees and then adds the direction of the magnetic field lines of the Earth to precisely determine the location of the flower. For example, if the bee determines that the flower is 45 degrees to the right of the sun and 20 degrees to the north of the magnetic field lines of the Earth, then the bee can easily locate the flower. If it forgets the location of the flower, it can use the same method to find it again. Of course, bees don't really do complex calculations in their heads. All of this is done instinctively. Scientists have discovered that bees can sense the Earth's magnetic field through their compound eyes. When bees fly, they can see the sky, the ground, and the polarization of light reflected from the sky through their compound eyes. By integrating the signals sent by the photoreceptors in their eyes, bees can determine the exact location of the sun. This allows them to memorize the location of the flowers accurately. Not only do they memorize the direction of the flowers, but they also memorize the distance. How do they memorize the distance? This is related to the structure of their legs. A bee's leg is divided into three sections: the trochanter, the femur, and the tibia. The muscles of the bee are attached to the trochanter. When the muscles contract, the femur moves up and down. Since the length of the femur is known, the distance traveled by the femur indicates the distance traveled by the bee. Therefore, the bee can calculate the distance traveled by recording the number of times its femur moves up and down. Some people might ask, do bees really move their legs while walking? Have you ever paid attention to how a bee walks? When a bee walks, its legs are always fully stretched out and don't move up and down. So this theory doesn't seem to hold up. In fact, the bee calculates the distance traveled while flying, not while walking. In addition to the distance, the bees also need to memorize the time it takes for the flower to bloom. Only when the flower is in full bloom will there be sweet nectar and fresh pollen. If it's too early or too late, there won't be any food. So bees memorize the time it takes for the flower to bloom. For example, if a bee finds a flower containing nectar at 10 o'clock in the morning, it will return to the hive and inform its teammates that there is a flower full of nectar at a certain location. At the same time, it will also remind its teammates that the flower will bloom at around 10 o'clock in the morning, and they should go there at that time to collect pollen and nectar. In this way, through the waggle dance, the bee can memorize the location, direction, distance, and blooming time of the flower, which makes it easier to find the flower next time. This is like giving your friend detailed directions and telling them to go there at a certain time. Isn't it amazing? So you see, memorizing the location of the flower is extremely important for the bees. It allows them to work more efficiently and ensures the survival of the entire hive. Without this ability, they wouldn't be able to survive. At the same time, bees have this ability because they are excellent pilots. They can fly in a straight line and keep the angle between their bodies and the sun at a constant 45 degrees. They can also sense the direction of the Earth's magnetic field through their compound eyes. Otherwise, they wouldn't be able to return to the hive after memorizing the location of the flower. However, the most important thing is that bees have a keen sense of smell. Otherwise, they wouldn't be able to smell the flowers from a long distance away and wouldn't be able to find the flowers even if they knew the exact location. In nature, bees are not only diligent gardeners, but also excellent pilots and locators. These abilities allow them to play a vital role in our lives. Without bees, the world would be a very different place. So after watching this video, have you ever looked at a bee in a different way? Welcome to share your thoughts in the comments section. Alright little friends, today's video comes to an end. Don't forget to subscribe and hit the bell icon. We'll see you next time.